In this video, I want to talk about the general information of the areas of sector and segment, just so that we can have a little bit understanding of it. If the central angle denoted by theta is in degrees form, then the formula for the area of a sector, capital A subsector, is equal to the central angle theta divided by 360 degrees, which is a total degree that you get when you go around a circle, multiplied by the area of a circle, which is pi times the radius square. If the central angle theta is given in the radian form, then the formula for the area of a sector is very similar to that, except that instead of having theta over 360 degrees, now you got theta divided by the number 2, and you're still multiplying that by the radius square. But regardless whether your central angle is in degree form, in radian form, you're still going to end up with the area of a circle in the middle of your work. Now, what is a sector? Well, the sector is this part right here. So this whole thing is a sector. The shaded part in the green here is called a segment. The line that connects the two endpoints of these two radii or these two radiuses is called a chord. How do we interpret the area of a sector? Well, the way I like to think about it is that the area of a sector is a portion of the area of the entire circle. So the area of a circle is pi times radius square. So the area of a circle is that. But instead of finding the area of the entire circle, now I just want to find the area of just a portion of it. And that portion is called the specific part of the formula for the area of a sector that really motivates me to think about the area of a sector that way is the division of the central angle by 360 degrees here. So the way that I like to think of this formula in general is that I like to think of it as a portion of which usually indicates multiplication when you have to do like percentage problem, for example. A portion of the area of the entire circle, recall that in a percentage problem, if you were asked to find 15% of regular price of a pair of shoes, well, that word of in that percentage problem indicates multiplication. Something of something else means something multiplies that something else. Well, same thing right here. The way I like to think about this sector area formula is a portion of the area of the entire circle. So that's why there's multiplication in here, and that portion is the division of the central angle over the total degrees, which you get when you go all the way around a circle. Now, what about the area of a segment? Well, the area of a segment can be found by subtracting the area of a triangle from the area of a sector, because the area of a sector consists of the area of a segment plus the area of a triangle. So going back to this general figure, you see you have a sector right here. But inside a sector, you have a segment, which is this part shaded in the green, and you have a triangle right here. So you can easily see that, oh, okay, the area of a sector is just the segment area plus the triangle area. So that's why all you have to do is that you just subtract the area of a triangle from the area of a sector, and your leftover is the area of a segment. So that's the way you would be able to find the area of a segment in general. But there are some problems where you probably had to come up with like a similar version of this general formula for the area of a segment, and we'll go over some example where the area of a segment can be found by using this formula or in a similar fashion, but the way you do it is still, I would say still relatively the same or extremely similar